in this lesson, we'll approximate the impeller bottom plane and the internal cylindrical surface and create a local coordinate system based on the approximated surfaces. We have a scanned model, the impeller. As you can see, it includes both simple elements like a plane or a cylinder, as well as the complex surfaces of the blades. We'll reconstruct the impeller as a solid model based on this scan. The model is represented as a polygonal object. You can see it in the tree. The representation of triangulation data in polygonal objects allows you to decrease the size of model files and accelerate work with it. The impeller body is placed at some distance from the origin. It's a peculiarity of this scan. This position is not comfortable for modeling. We can't move the body, but we can create a local coordinate system and set it as current. For this, we need base objects. We'll use the bottom flat surface of the impeller and this cylindrical hole. To create parametric base objects by approximating the bottom surface, let's use the Surface Adjustment command from the Modeling menu. First, select the surface type from the drop-down list. It will be plane. Click the Select Triangles button. The cursor has changed shape. It's a brush. You can select the triangles with it by holding down the left mouse button. It's possible to change the brush size. Let's increase it and select the impeller bottom. If you selected something extra, set the switch to the exclude position and deselect the extra elements. You don't need to select all the triangles. These are enough. When you've finished, click Create Object. The plane preview will appear. We don't have any other objects to align the plane with, so we can't do anything else here. Let's complete the command and create the plane. Let me hide it for a while. It will hinder us from creating a cylinder. Now select the cylinder surface type. Click the plus button. Adjust the brush size if needed, and select the triangles forming the cylindrical hole. Confirm. The cylinder preview has appeared. Now I can already align the cylindrical surface with the plane. Activate the Guiding Object field, unhide, and select the plane in the graphic area. The system will slightly rotate the cylinder so that its axis becomes perpendicular to the plane. This rotation is subtle and may be hard to notice. Let's cancel, zoom in, and repeat the steps to better observe the adjustment. Another parameter we can adjust here is the cylinder radius. You can see the radius value that was determined automatically. I've decided to round all values to one decimal place, using only 0 or 5 as the digit after the decimal. Enable parameter management. Enter 10.5 into the radius field. If you made a mistake or forget the original value, disable the switch and the original value will be restored. Let me return the value and confirm. Stop the command. Let's hide the polygonal model and examine the new elements. You can notice that the plane and cylinder are represented in the tree as elements without history, so it's impossible to edit them. However, we can use these objects as base ones to create auxiliary elements. Create an axis for the cylinder using the centerline command. Select the cylinder, confirm, stop the command. Also, you can use objects without history for measurements. For example, you can measure the angle between the axis and the plane to verify that it's equal to 90 degrees. We'll create a local coordinate system with its origin at the intersection of the axis and the plane. You can create the point in advance using the Point on Intersection command, or you can start the local coordinate system command and click Build Point. Select Point on Intersection, select the axis and the plane. The preview appears. Confirm. Then let's define the orientation for the local coordinate system. Activate the y-axis field and select the cylinder as the guiding object. This will align the y-axis parallel to the cylinder axis. You can select this axis as well. Confirm the creation of the local coordinate system. Stop. The coordinate system has appeared in the tree and is set as current. All subsequent elements will be created relative to this coordinate system. Don't forget to save your work.